This is an example of a mass-mass conversion problem for stoichiometry. If you look at the problem, it reads how many grams of water can be made by burning 50 grams of propane, which is C3H8, in sufficient oxygen. Now, when you read the problem, the reason you know that it's mass-mass is because the question is asking you how many grams of water can be made by burning 50 grams of propane. Since both the given and what you're trying to find are mass problems, then, or mass units, that is what makes it a mass-mass problem. Now, the first step in writing any of these or doing these problems is to write a balanced equation. And so it's from the reading of the problem that you'll figure out what you're doing. It's asking you how many grams of water can be made. So we know water, H2O, is a product. And we know that we're burning propane, C3H8, in oxygen. So we're going to react C3H8 with oxygen, which is O2 because it's diatomic. Now, if you look at the parts of the equation that we have here, you can see that it's going to be a combustion reaction. So a combustion reaction of a carbon and hydrogen containing compound always produces water and CO2. Now, a lot of students get hung up on that word in the problem where it says sufficient. And sufficient just means enough oxygen. So what this is trying to tell you is that you have enough oxygen for this reaction to happen as is, using the numbers that I gave you. Now, we haven't balanced this equation yet. So if you go through and balance it, you'll see that you need a 3 in front of the CO2, a 4 in front of the H2O, and then lastly, a 5 in front of the O2. Then to get started on the stoichiometry part of the problem, you want to put in your unknowns and your knowns. So if you read, you're looking at how many grams of water. That is your question mark under the water with a gram symbol. You do know that you have 50.0 grams of propane. And this will give you your starting and ending point for your path. You always start with the given, and you want to convert from grams of that given to moles. So in this case, grams of C3H8 to moles of C3H8. Then once we have moles, we want to convert it to moles of water, and then lastly 2 grams of water. So this gives you your pathway that you should follow. We're going to start out with the number that was given, 50.0 grams of C3H8. And to change that to moles, we're going to multiply by a conversion factor. We want to change it to moles, so that's the label that will go on the top, moles of C3H8 over grams of C3H8. Now, whenever you have a mole over gram step, you always put a 1 by the mole, and you look at your periodic table to figure out the molar masses of the C's and the H's. When you total that up, you should get 44.11 grams. The next conversion is to go from moles of C3H8 to moles of H2O. Since I'm converting to moles of H2O, I put that on the top. I want to get rid of moles of C3H8. That goes on the bottom. And this is the one step where you have to look at your balanced equation to figure out what you're going to do. You look at the coefficients. The coefficient in front of the water is a 4. So therefore, we want to use a 4 for our number of moles of H2O. If you look at the coefficient in front of C3H8, it's an understood 1. So we put a 1 in front of moles of C3H8. From that step, our last conversion is to convert from moles of H2O to grams of H2O. And we know that 1 mole has 18.02 grams based on our masses on the periodic table. Now you just use your calculator to do the math. Our answer can only have 3 significant digits, so we should write 81.7 grams of H2O. And that's how you do a mass-mass stoichiometry problem.